All right, let's talk about two of the most powerful tools in the C-sharp world, but ones that often kind of work in the shadows: delegates and events. You can almost think of them as secret agents for your code. And in this explainer, we're going to blow their cover and figure out what their missions really are. So why all the mystery? Well, when you first look at delegates and events, they seem pretty much the same, right? But here's the secrets. They have completely different jobs. And honestly, figuring out that difference is the key to writing a way cleaner, way more efficient C-sharp code. It all boils down to one fundamental problem: communication. How do you get different pieces of your software to talk to each other without creating a tangled mess of spaghetti code? You want it so a change in one place doesn't break everything else. This idea is called decoupling, and it's exactly the kind of mission our two secret agents were designed for. First up, let's put our first suspect, the delegate, under the microscope. Probably the best way to get your head around it is to think of a delegate as your code's own personal planner, a specialist you bring in to handle a very specific list of jobs. So imagine you're planning a wedding. You go out and hire a wedding planner, and you hand them a list. Okay, I need you to manage the ceremony, and I need you to organize the reception. As the client, you don't really need to know all the tiny details of how they do it. You just trust that when you give the signal, that planner's going to get those specific tasks done. And here's the cool part. That analogy maps perfectly to the code. A delegate is basically a contract or a type-safe function pointer. It is the planner. It holds a list of methods, our tasks, that all fit a specific description, all ready to be executed the moment you say go. And this gives you some serious superpowers. First, you can call methods indirectly, kind of like using a remote control for your code. Second, they're type safe, which is just a fancy way of saying you can't accidentally give your caterer the instructions for the DJ. It prevents mistakes. And third, they are incredibly flexible. You can literally pass entire chunks of behavior around in your code, just like handing off that to-do list. The actual process is super straightforward. First, you declare the delegate. That's like creating the blueprint for the plan. Then you assign specific methods to it, like adding manage ceremony and organize reception to the list. And finally, you just invoke the delegate, and boom, it runs through every task you gave it. Simple, direct, and powerful.
All right, so that's agent number one. Now, let's bring in our second suspect, the event. And if the delegate is a personal planner with a specific list, the event is something much, much bigger. It's more like a public broadcast system.
Just think about a news agency when a huge story breaks. They broadcast it out on every channel. The agency has no idea who's watching at home, who's listening in their car, or who's seeing it on their phone. They just send the signal out there. And anyone who's decided to tune in, the subscribers, they get the news. This is what we call the classic publisher-subscriber model. The event is the official channel. One object, the publisher, sends out a notification that, hey, something important just happened. And any other objects, the subscribers, can choose to listen in and react to that news if they care about it. So events are all about broadcasting notifications. The key thing here is the publisher doesn't know and doesn't care who's listening. And that creates this beautiful decoupling where different parts of your application can react to things without being directly wired together at all. And the flow here is just as clean. The news agency class just declares that it has a news broadcast event. Then any other part of the code that's interested can subscribe to it. And finally, when the time is right, the agency just triggers the event, and every single subscriber gets notified instantly all at once. Okay, we've interrogated both of our secret agents. Now it's time for the lineup. Let's put them side by side and make the differences absolutely crystal clear. This table really nails it. For delegates, the communication is direct invocation. The code that calls the delegate knows exactly what's on that to-do list. But with events, it's the publisher-subscriber model. The publisher is just shouting into the void with no idea who, if anyone, is actually listening. So here's the real bottom line, the rule of thumb. Use a delegate when you need to hand off a specific, known set of instructions to another piece of code, but use an event when you just need to announce that something happened, and then let other, totally unknown parts of your code decide for themselves if they want to react. And that's the verdict. Once you really get this fundamental difference, you stop just writing lines of code and you start orchestrating it. You start building applications that are more robust, more flexible, and honestly, just way easier to manage down the road. You know, there's this great quote from our source material that just perfectly captures this whole idea. It says that delegates and events are the conductors in the symphony of programming. They don't play the instruments themselves, but they're the ones making sure every part of the orchestra works together in perfect harmony. I love that. So, I'll leave you with this final thought. The next time you sit down to design a new feature, picture your code as a full orchestra, and then ask yourself, does this moment need a direct, specific command from the conductor, or does it just need a broadcast announcement that lets the right sections of the orchestra respond on their own? The answer will tell you exactly which tool you need for the job.